okay. And then we talked for 30 minutes about the applications of AI in the classroom and how it's like polarized and if it's a good or a bad thing.
Yep.
Okay, so we're going to do section 3.5 is about math modeling and variation. So I didn't write that last time. And variation. So if I say that the model of population of the United States is given by this table, so I have year here, and I'm going to use variable t.
Why did you use so many different colors?
Just because,
Colorful.
no reason.
No, I liked it. I was just wondering.
So if I say 2003, 2004, 2005.
Does that say variation?
Yes.
Variation, yeah.
Should we write
2008,
this down, the
2009. Yes, you should write this down. So population is 290.1. What does it mean if I write 290.1 or 292.8 or 295?
292,800,000.
Right. So if I get an answer and I say what is the population in 2005, would you write your answer as 292.8 and put a box around it and be done?
No.
No, that would be crazy. What would you do?
I would say 292,800,000.
So you could say 292, comma 800, comma 800. What?
People.
What's your unit?
Homies.
People. And I would say you could do it that way, or you could write what?
People.
No, it's not 292.8 people.
Million. People.
Million people. So last semester, to somebody's dismay, I said if you box your answer and you leave off the units, it's half of the problem wrong. And I got a big kick out of somebody's reaction when they said that's too much. Like taking off half the points for leaving off the units is too much. That makes my math teacher heart very happy that you think that, because that's how much I want you to include the units.
Wait,
What?
if you just box it, like, even if you have it.
No. I wasn't saying the where the boxes go. I'm saying if you
Oh.
just answer this way or this way,
Okay.
like maybe I give you a formula and you figure out that in 2004, the answer that you get out of the formula is 292.8 because your calculator even told you so.
Oh,
That is half wrong
then you have a million people.
because you didn't put units.
The Box by Roddy Rich.
So 2006 is 298.4, 2007 is 301.2, 304.1, 306.8, and 308.7.
Are these realistic numbers?
I believe so.
I tried doing the homework
Ahead of time?
yesterday. Yeah, I tried doing it yesterday before we did this, and I like even went through the textbook to try and read this section, figure it out. I could not figure out for the life of me how you build the equation based on the graph.
So they didn't.
No, but it was like one of the homework questions was like build an equation based on.
Oh, I see. So that's something I'm going to show you how to do. So what do I mean when I say that there's a linear model?
Straight.
Yeah,
No curves.
right, no curves. So the graph might look like what?
Rising.
It could be rising, could be falling, could be level. It's not level. It's not falling. It's rising, but it's all going to be kind of like
It's
this.
gonna be like a best fit line, isn't it?
Oh, line of best fit. I like that. So you might, for example, we might learn how to use our calculators to find a line of best fit. I don't know why it's called this, but if you look in your calculator, you'll find how to do a linear regression. I don't know what's regressive about it, but this is called a linear regression or line of best fit. If your data looks like this, or if your data looks like this,
Holy.
I could see that data might be susceptible to a line of best fit.
That doesn't make sense. That was population.
Um,
Can you
right,
scroll back up a little bit, please?
right. Not really talking about population. I'm just talking about line of best fit. But if you had data that looked like this,
I understand.
does that seem like line of best fit might be a good way to
Would we use
approximate the data?
No.
sig figs
No.
for measurements?
It wouldn't be, but we could use polynomials to do a to do curve fitting instead of line fitting. So
Would that be a polynomial model?
yeah,
Okay.
right. So the example in the book says a linear model that approximates this data is y equals 2.72 t. What is t?
Time.
Plus 282.0. I don't know. Is there a better answer than time? What is t in this case?
Year.
Yeah, it's year. Right. And then this the model specifies that t is between 3 and 10. And what does that mean?
3 and 10 years.
So-
Between 2003 and
2003. So
Yes.
so this is when so this is t equals 2003.
Is next to like where like you wrote the years out, is that supposed to be an X or is it T?
Here,
Yeah, right there.
that's
So
t.
It's T.
Yeah, that's t. And they specify this by saying, here's your linear model with t between 3 and 10, where t equals 3 corresponds to 2003. Just so it's clear. And when you're doing these models, you could do t equals 0 corresponds to 2003. It might be convenient to remember that the t equals 3 is 2003 because it's the same last digit, but there's no requirement for that. It might be just convenient to do it that way. So the problem might say plot the actual data and the model on the same set of coordinates.
Not looking at my phone, I just can't see. What's that word? Plot the.
Plot the actual data, and the model on the same set of coordinates. So what would that look like? How would I do that? Should we go to Desmos?
For
Yeah.
sure.
Is anybody still writing? Can I switch over?
I'm writing, but you're chilling.
In the model, and it says, plot the actual data and the model.
On the same set of coordinates. All right, so let's go over to Desmos. And do you know how to make a table in Desmos?
See,
How? Come
so
on.
you go to the plus sign and the
Plus sign,
and then table.
and then table, and then
That's basically it.
and then what do I put in? What do I put in?
Your years. What like
3.
how to change?
Oh,
like,
that's I like that. Why 3?
2003.
Ooh, 3 or 2003?
3.
3.
Which one?
3.
Okay, why?
No, 3 to represent 2003.
3 to represent 2003. I agree with that. Why?
Because 3 is easy.
Well, that's okay. 3 is easier than 2003 is not a super great answer.
I mean,
Well, it's because 2003 would be like all the way over there.
I'm not. Yeah.
That's also true, but I can scroll over. So
Yeah,
I
but,
can.
like,
So
it's
my little
easier
gear.
not to scroll over.
It's
My gear
simplified on the
here.
graph.
But it's in the equation.
Right. That's the real reason. Over here on my gear. On my wrench button, I could say X goes from 2000 to 2008. So I can, or I can just scroll over. So that's not the real reason. The real reason is because that's what the formula uses. So for 3, I have 290.1, and then for 4, is that a mark on my screen or is that a point? It's a mark on my screen. 4, I have 292.8. And then for 5, all the way down. So I'm holding my fingers one above the other and I'm pinching vertically because my
That's
points
awful.
are way up here. I could just go in here if I don't want to do it that way. I could go in and say y-axis goes from 0 to 310.
How does Braille work on Desmos?
You got me. If I have a screen reader that makes the dots, I guess. You see that? You see the limits are in Braille now.
Wow, look at that. Need a.
Okay, so that's pretty good. So 5 is 295.5. I'm just gonna put in these 3, and then how do I put in the model?
You like, well, you have to make another table, I guess.
No, incorrect.
Okay.
How do I put in the model?
Do you need to finish the table first?
I'm just being lazy.
Okay.
Yes, I would for the homework assignment. I would go up through 2010. Yes. So how do I put in the model now?
Oh, isn't it?
Annabelle.
Plus sign right there.
Yeah?
How do I put in the model? I've put in the table. I've given a representative sample of 3, but really you should do all 10
Mm-hmm.
just by continuing the table.
And now you have to make your line of regression or line
Yes.
of it, right?
Yes. How do I do that?
Well, you do 3, right? And then it's like t is either larger or equal to t, right? It's like big line.
Oh, okay. So I'm limiting. Oh, okay.
Should we not
yeah.
limit? Or,
No.
Yeah. Let's just do the line.
okay. Well,
So-
it would be y equals 2.72 t, right?
Yep.
And then,
Well, there's no T.
or not t, but like just in general, like that's what it stands for. Right?
So what? So I'm translating it into terms that Desmos can handle. So how should I type it into Desmos?
Well, wouldn't T
just
be
like,
3? So it'd be 2.72.
Y is y. Y is so my model says y equals something. I'm going to use y for y. So in Desmos, y is the same as y. It doesn't change. But T doesn't exist. What am I going to?
F you
Yes.
If you did,
and then plus 282.0,
Right.
and then you have to put your limits in.
Right. And I don't remember how to do that
oh wait,
in
no, it's
Desmos.
not 0.1, it's 0.0, I thought.
0.0, right. It's my third attempt to try to put 0.0. Yeah, and then maybe I could just make the line smaller or something, or make the dots bigger. What about a small solid line? 1. There we go. And then there's a way in Desmos to specify
I'm not sure.
limits. Maybe it's this. Maybe it's comma 3 is less than or equal to x is less than or equal to 10. No, that didn't do it. I don't remember off the top of my head. Sorry. If there's a way to do it. I just don't remember. But I don't really care about that part. Whoops. I don't care about that part. So if you're putting the line of best fit in, you don't really have to have the 3 is less than or equal to t is less than or equal to 10. So that's for comparison. So good job on that. So what did we think about, before I destroyed my line, what did we think about how well the model fitted the data?
It fit well.
Yeah.
It fit well?
I think so.
I think so. So it was a pretty good predictor. So this model is not the actual number for the data, but it might be a line of best fit. It might be a linear regression. It might be a good approximation. So if I said, could I use this? Could I use this to see what the population is in 2011? So this is a trick question. Can I use this model to see what the actual population actually is in actual 2011? No.
No.
What can I do with this model?
You can predict.
Yeah, I can predict it, and that's like it's like giving an approximation or an estimate, right? So based on this model, which we verified on the data, because hypothetically I put in all 10 points, I mean all the way through 2010. And I said, that's a pretty good fit. I bet the trend is going to continue to 2011. What does the model predict for 2011? How would I do that?
You use the formula.
And so predict population in 2020. So how would I do that?
Function.
So what's my function? So it's y of t, right?
Yeah.
Is this thing?
Yeah.
Y of t is 2011.
Say it again. I don't really know if I agree with
Y
that.
of 3 is 11.
So
No.
I don't know.
How do I evaluate at a particular number?
that you do.
Kira.
Well, because we use like 3 and 10, probably the ones we're just gonna use 20, and then you're gonna.
So
get-
t equals 20
Yeah,
corresponds
to 2020.
to 2020. And so what do I do with my t equals 20?
You just plug in 20, so it would be like y of 20 equals 2.72 times 20 plus 282.9.
Can somebody put that in your calculator and tell me what that is? Tell me what the proper answer is that I would write on my homework or test.
Then
What's the word before population?
Predict. So the whole thing would be use the model to predict what the population in 2020 would be. So did you figure it out?
I'm in the process of that.
So you literally just do 2.72 times 20 plus 282.
yeah.
Only one person has their calculator out and is attempting this?
I'm still writing. You write paragraphs at a time.
I don't know the answer to this.
What's your answer?
It's like 336.4.
336.4 billion.
Stop.
Million?
Not funny.
So if you look back, the problem tells you that that this data models in millions of people. So t is a little bit funky because it's 3 instead of 2003, and why is a little bit counterintuitive or specific in a weird way because it's not 290.1 people. So if you get 336.4, I tend to think that that's a reasonable answer because just the way they're looking at this, the way the numbers are going. I'm not mad at 336.4, but I would not give that full credit.
Yeah, that's only half credit.
It's only half credit. Why?
Because there is no
You need your
Fix it.
unit.
Fix it.
336.4 million.
Million
That's not true, right?
people
Not that many people.
in the United States in 2020.
Oh, I thought it was in the entire world.
No, this is
You need a
this is the
lot.
population Y in millions of the United States.
I didn't read that.
Yeah, it's even in
What,
colors.
what was the population?
That.
No. Yeah, let's look it up to see how.
So this is a properly formatted answer. So that's full credit for that one because you included units and you interpreted your data.
Why do we have to put the .0 after today too?
Sorry? Oh. Okay, so I don't really talk about significant figures a ton in this class. I mostly just say express your answer to 3 decimal places, and I expect you to calculate it to 4 decimal places and see if there's any rounding that needs to happen.
I don't need any more sig figs in my life.
You know, it's not a useless discussion because when you put something in your calculator and you say there's there's 2 pizzas here and 7 people, how many slices should you have? And maybe there's 6 slices per pizza, so you multiply it out. You got 12 slices for 7 people. Can you divide 12 by 7 for me
Probably not.
on your calculator?
Yeah, I can't do that.
And give me all the digits.
1.714857114. And that probably repeats.
And it might be repeating. Do we need 12 digits of precision on slices of pizza? Or should you get either 1 or 2?
You get 1 or 2.
Maybe each person gets a 1.5 slices.
Yeah, I feel like we put them into tiny little ones.
This is why significant figures matter, because the calculator is going to give you as many digits as it can hold on the screen. And I don't care what the last digits are. They don't do anything for you. So if you have a real world problem, like we have 12 slices and there's 7 people, maybe we use our calculator, but then we come up and say, you know what? Let's everyone take a slice and a half and then see where we are. So the significant digits that I want is probably 2. And for a real world application, I might say 1.5. That's why significant figures are good. I don't really talk about them a lot in this class because it's not an application that I'm particularly interested in, but don't be mad at significant figures because you can give 20 places of precision that don't mean anything. That's why you chop them off and you use significant figures. All right, I don't know if we're going to have time for this, but I'm going to try.
I think class just ended.
No, we got 3 minutes.
Oh, we do?
Yeah.
The class next to us just always gets out super.
Find a least
You don't like liars.
squares regression line. Boys, you're both the prettiest. So if I say year is 2003, 2004, 5, 6, 7, 8, 9, and 2010, and I say Medicare enrollees, and I'm going to use variable E for that, and I say this is in millions. Can everyone take their calculator out, please? and I'm gonna say 2003 was 41.2 million people, 41.9, 42.6, 43.4, 44.4, 45.5. Are you guessing? 46.6
7.
and 47.5.
7.
5.
You really want to do 7?
So you can go into your calculator and you can put this data into a table. So let's do that. We've got a minute and a half. I believe in you. Let's go.
I don't
Woman
believe-
soul.
I don't believe myself.
Hmm?
I don't believe.
I believe in you.
No, I'm not.
Okay. Probably when we come back, probably next time, there's a statistics and a table, stat table, function in your calculator, and you can put in 2003, 2004, or you probably put in 3, 4, 5 through 10 actually, because we're going to let 2003 t equal 3 represent 2003. And then you're going to put those numbers in, and then you're going to use the linear regression function of your calculator starting next class.